discussion, we were discussing about the differences between the two. We discussed what is SAST, we discussed what is DAST, static application security testing, dynamic application security testing. All of you had quite insightful inputs to give that Rohan, this is SAST, wherein you are analyzing the source code. You will be getting the source code from the client or from your organization. They will be giving you the source code. You have to analyze the code, you have to go through the files, you have to go through the source code and understand what is happening. So when you are analyzing the source code, you call it SAST. When you are doing a DAST, that is dynamic application security testing, you will be running the application, and in the runtime you will see what is happening. You will do one of the things, that is debugging. We have discussed debugging previously when we were discussing about ADB, that is Android Debug Bridge. In that case, we had discussed about debugging, wherein what we were doing, all of the requests that are being made, all of the API calls that are happening. API calls here refers to the Java API, the native libraries that you have in the Android architecture. All of those Java APIs, all those libraries that are being used, the dependencies that you have, what is happening there, how is the application working, if there is any of the class or there is any of the method that is being used. In Java, we have discussed about classes, we have discussed about methods, so I'm referring to them here. So which of the classes are being used, which of the methods are being used, that is what we will be discussing here. You mentioned that Rohan, in any of the company, when you're working as a pen tester, when you are doing a VAPT, there are a lot of tools that are available online as well. Like we had discussed about ImmuniWeb. ImmuniWeb is one of the most popular, online resource, online tool. All you have to do here is you open immuniweb.com/mobile. You upload your APK here. It may be an Android app, or if in case it's an iOS app, you simply give its file. It will be uploaded to the server. It will be testing. It will be using, and then we will be able to go ahead with it. Here it will be testing for 𝗲𝗂𝗶 top 10, OWASP mobile top 10. Here all of the various permissions it requires, whether there is any of the external communication, like if it has any of the malware embedded, you will be able to see the external communications as well. So all of those things you will be able to see here. This is an online platform. In some cases, you will not be able to use the online platform when the app that you are testing, the APK that you are testing, it's a private application. And when you upload anything here, you consider that this APK will now be in the public domain. So for that reason, you cannot use these types of online scanners. Apart from this, there are other scanners as well that are available online. You just have to upload the app, get yourself a cup of coffee, you sip it, and the scanning will happen in the backend. It will show you the results, that these are the security issues that you have. You manually validate them, you create a report, and you submit. These are the online scanners. I do not want you to rely on any of these scanners. They can give you a brief idea that okay, this is what is happening here, this is the application, these are the services, the security issue can be there. In our upcoming discussions as well, we will majorly be focusing on the manual approach. We are discussing the automated approach so that you get an idea that okay, in the automated part, in the vulnerability assessment phase, this is what we do. All of the things that this application, that ImmuniWeb is doing here, we will learn how to look out for all of these security issues manually. By the end of this training, you will be able to look out for all of the security issues in any of the Android app on your own without external support. Okay, so this is one of the platforms. Apart from that, I also introduced you to MobSF, that is Mobile Security Framework, that is not necessarily only associated with this one, Android. It can also help you with iOS testing. So this is MobSF. This has been developed by OpenSecurity.in. Some of the developers, they group together and they belong to the southern part of India, Here they have developed it. They also run their organization wherein they offer pen testing as a service. You can go to them, get yourself a package, and they will be performing the testing of your application. They have developed MobSF. MobSF can help you with both Android iOS. It can help you with static testing, that is static analysis, dynamic analysis, how to use it, how to install it. We have already discussed. How do you install Docker in your Linux machine? We have already discussed. So I am here assuming that all of you have got MobSF ready. If it is not ready, please stay back after today's discussion and I will help you with it. All of the lab setup. MobSF is important for you to know, for you to understand how vulnerability assessment happens. So here I am assuming that you have got MobSF ready. We have discussed it in detail in the previous discussion on how do you use MobSF. Okay, how do you install MobSF? How do you configure it? How do you use it? We will be discussing today. What I have chosen for today is that instead of using an vulnerable application, I have chosen an application that is live, because here we are also discussing the bug hunting approach. So I went to bugcrowd.com. I chose the category as Android, that I would want to see all of those programs that have Androids, Android apps or Android APKs in their this one asset in scope. Here I have found Monash University Bug Bounty. Here it is. So here it is Monash University Bug Bounty. Here these are all of their assets, and here this is the Android app. Because all of us are dedicated towards learning Android pen testing in detail. For that reason, at the moment, I will only be scoping ourselves towards this app. So this is the app that we have. What we need is this app that we have here, this that is available on Play Store. We will be requiring its APK. Now for us to be able to get its APK, there are multiple ways by which we can get it. The easiest of all is you simply open this in your emulator. Like this is my Genymotion emulator. I go to Play Store. Please make sure that if you want to use Play Store in your emulator, you need to log in with a Google account here. You may choose your primary account here, primary Google account, or you can create a Google account for testing. So here I have, the app is Monash Study. This is Monash Study app. It is by Monash University. Is it not available at our location? This app is available for your device. So from here we can simply open it. Like if I open this, I copy this URL, I go to my browser here in my emulator. I am demonstrating the bug hunting approach, that when you are hunting for bugs, this is what you do. So this is your bug bounty program. We have already discussed it in detail in our previous discussions on how do you go through the bug bounty program guidelines. So this, your device isn't compatible with this version, maybe because we are using an older version of Android. For that reason, it is not allowing us to download it. For that reason, as an alternative, what we can do, we can directly look for the APKs of Monash Study. There are a lot of platforms available. You can simply go to Google and you search for download Monash Study APK, and from here you can directly download the APK. So in some of the cases you will also be able to understand the versions. Here they will be mentioning the versions, that this is the particular app, this is the version that you have to test. In the actual pen testing that you will be doing, they will be giving you the APK. Along with that, they will also be giving you the MD5 or the SHA1 hash, so that when you are giving the report, they will also be validating that the app that you have tested and the app that we have given are both of them same. So in the report you will mention this is the APK and this is the hash of the APK that we have tested. So that hash will be matched with the APK that they have given you, so they can verify that yes, this is the application that we gave it to them for testing here. So just for the sake of demonstration, I looked up for Monash Monash study APK, and here I got this from Softonic. From here you can download it. There are other ones as well like APKDL, APK Pure. There are a lot of platforms where you can search for the APKs, even for the previous versions or the current versions, and you can download them. Now, if in case you have downloaded them from the Google Play Store, so they will be installed in your device. With the help of ADB pull, you can pull the APK from this particular device. We have already seen it previously for any of the app. How do you extract the APK? If you are directly downloading the APK from here, though this is not recommended, this will be creating some of the challenges like the version might mismatch. Here this is the latest version and 9.4.10, 9.41.0, this is the version that you are testing. Always double triple check that the application that you are downloading, the APK that you are downloading and the APK that you have here are the same. In some cases, bug bounty programs will give you the link to their Google Play Store. In some cases, they will be hosting their APKs on their own web server, and they will tell you that if you want to download, simply click on this link and then this application will be downloaded. So any of the things can happen. You will have to go through the program guidelines here. So this is the APK that we have. I have already downloaded the APK. Here you will be able to find it. As in the previous discussion, we have discussed that MobSF can be ran as a Docker image, as a Docker container image. So you can simply set this up in your MobXler. I already have it up and running. So as to save your time, I just open this here. In the previous discussion we have seen this, that how do you get your container up, how do you get this done. We have already discussed it, so here I'm assuming and I'm hopeful that all of you have got your MobSF up and running. So when you will be opening MobSF for the first time, like when no scan is running, you will be able to see it like this. So this IP will be changing. For you to be able to get this IP, you go to your VM and you write ifconfig. Then the IP that is associated with your VM, like 192.168.206.132, you enter that IP here over the port 8000. Now, how did I come to know that it is running on the port 8000? Here, listening at all of the interfaces 0000 over the port 8000. So here in another terminal, you run ifconfig, you get the IP address of the VM, here you get the port number, you go to your browser and here this is done. So when you will be running it for the first time, when no scans are running, this is what you will get to see. You simply take your APK, like this is the APK that I downloaded, you take it here and upload it. Either you can drag and drop or you can click on upload. You will be having the prompt for file selector. You select and you can upload here. Now because this analysis has already been done, for that reason we are able to say this so quickly. When it will be happening for the first time, it will be taking some time. For example, if I try to download this app like Be Safe Android app, so if I try to get its APK, download Be Safe Android app APK, Be Safe for Android, Be Safe by Beeper. Okay, let's see if we are on the right app. This is Monash Be Safe. We need to download this. Google.com Monash Be Safe APK download.
Rohan, so whenever we are not downloading from Google Play Store, how can we believe these sites are genuine for giving the APKs?
You don't believe. As I mentioned, As I mentioned, you never download APKs from here. I am doing
Okay.
it for the sake of demonstration. You do not do this, please. Not for
Okay.
your
Okay.
personal consumption, nor for the testing. The original app developers might not have added malwares, but when I'm not naming any of the platform, but when any
Okay.
of the platform upload the APK here, how will they get the cost of the servers running? They have to store so many APKs. They need to have the network bandwidth for you to be able to download the APKs. So how will they get the cost? They add
Yeah.
malwares. Simple. So you don't follow this approach. I am doing this so I can demonstrate. Otherwise, in an ideal case situation, in pen testing, you will be having the APK given by the client. They will personally validate that yes, this is the APK that we want you to test. In bug hunting, you directly download them on your emulator because currently, because I'm demonstrating MobSF, I'm downloading the APK and uploading it. In actual bug hunting, this is not how it works. You have the APK, you have the app on Play Store, you download it on your phone. Because it's from Play Store, you can even download it on your own phone, your personal device. You use it. You first use it as an user, as an end user, as a consumer. You understand what that application does, what are the features it offers. Then you extract the APK using ADB, you upload that to MobSF, you analyze it, static analysis, dynamic analysis, then you do the bug hunting. So even the MobSF part is optional in bug hunting, but you may choose to do that. I am currently here demonstrating MobSF. For that, I require some live targets from Bug Bounty. I'm getting it. Yes, Bikram.
Yeah, thank you. So, what if the app given by the client is not supported by our emulator? So, do we need to reconfigure the emulator to get this app running? Sorry.
In most of the cases, what we do is the app that is provided by the clients, we let them know that this is the environment that we will be testing. So we will be testing it on the minimum SDK that they support. Like if they support Android 6, we will be testing it on Android 6. If it happens that the minimum SDK that they are supporting is for Android 9 or Android 10, we need to test it there because we know that their APK or their apps, when it will be given to the public, when it will be used by even for the internal users, they will be requiring this device. But as I have seen in my experience, they will be giving you the application that is supported on Android 5, 6, that the one that we have used. This is where the industry is at the moment. This is where the testing happens in the corporates. Even the bug hunting
Okay.
happens here. Because if you go to the
Thank you,
newer
Rohan.
versions,
Mm,
the challenge is if you go to the newer versions, the Android operating system themselves are secure. So if your application has any of the security issue and the Android is making efforts to hide that or to save the user from getting exploited, so you will not be able to find that the application is actually vulnerable or not. So we try to find out the security issues on the least version of Android possible so that we get minimum security support from the device. We want to make our
okay.
application robust regardless of on what platform is our user using it. Our application should be robust enough to be able to have or to be able to run it on any of the platform, least Android version possible. Okay, that is what we keep in mind.
Yeah. Thank you.
So from here we can get the APK. Like just for the sake of demonstration, I am taking this. It is Wink Video Enhancing Tool APK and download. So here this is the APK. Now for MobSF, as I was mentioning, that MobSF you can set it up locally in your Docker environment. Along with that, MobSF along like ImmuniWeb, it is also available as an online platform. So before I get to that, let me simply upload this APK here so that you get to know that how much time does it usually take for analyzing. So here this is uploaded analyze. I take this APK and I put this here. Now it will be uploaded, it will be analyzed, and we will get to know the results. Now it is analyzing. Depending upon how large the application is, how complex the application is, it will be taking time. It usually takes somewhere between 3 to 10 minutes depending upon the project. Sometimes it can go even more than that if in case your system configuration is not that strong. So it will be subject to a lot of variables, subject to a lot of factors, but on an average 3 to 10 minutes is what you require. You upload it here and it will be analyzing here. So here it is doing the static analysis at first. For now, I'll get to that in some time. I was mentioning that MobSF is available as a Docker image as well. Along with that, it is also available as an online platform. So if you open mobsf.live, you will be able to directly use it. Like if I show it to you in action, you simply open mobsf.live, enter, and then here it is. So this is the live website. So you simply upload your APK here. When you upload the APK here, it will be giving you a prompt. It will be giving you a warning like this, that this is a demo MobSF instance. Anything you upload here will be publicly available. Do you want to continue? The same concern that I mentioned yesterday, that if you are using any of the online scanners and you are uploading any of your asset there, asset here refers to the APK. So if you are uploading anything here, you should consider that your APK is now in the public domain. Anyone can now access it. So then you upload it here, it will be uploaded to the server. This is the server for MobSF. This is not a local instance, this is the server for MobSF. Now this application will be uploaded to their server, they will perform the analysis and they will let us know. Why should we be setting up our own Docker environment if in case we already have this here? The reason is for us to be able to perform the dynamic analysis, for us to be able to perform test of any of the application using MobSF, we need to integrate it with Genymotion. This online live website that we have that has MobSF, it is not integrated with any of the Android emulator. I took example of Genymotion because the lab setup that we have done, it has Genymotion. So if you are using any other emulator, like you are using anything from AVD, that is Android Virtual Device by Android Studio, or you are using any other emulator like Nox, Nox is another Android emulator. So if you are using any of them, you can integrate your local Docker instance for MobSF with that. In the previous discussion, we have seen how to do that. And if I show you the command here, this is the command. This is the command that you do. Only the thing that you change is this MobSF analyzer identifier. You get this IP and this port here. See 192.168.190.102, 192.168.190.102, 5555. So what this does is this particular application, this particular image that you have, this will get connected with Genymotion. So when you do dynamic analysis, we have discussed that in dynamic analysis we need to run the application. Where will you be running the application? In an emulator. So here this particular MobSF, when you will be doing the dynamic analysis, this will be the emulator where the dynamic analysis will happen. It is possible only in the local instance, but if in case you use this live website, you will not be able to run the dynamic analyzer because there is no Genymotion emulator that is connected with this particular version, with this particular online web version of MobSF. Now there could be a lot of reasons why this would have been done. Cost could be one of the things. Another reasons could be for the sake of security of this. Now if I can upload any of the application and I can get it installed, because when dynamic analysis happens, the app gets installed in their emulator. So if I can upload a malware, if I can upload a ransomware, if I can upload any of the backdoor onto their Genymotion emulator, things can go pretty wrong for them, because Genymotion will be connected to their network. It will be maybe either a bridged adapter or a NAT adapter, so I can traverse through their complete network, so it increases their attack surface a lot. For that reason, this is the most probable reason. I haven't had a chance to meet the developers of MobSF yet, so this could be the most probable reasons that I could think. This is what my logical reasoning says, that because here in MobSF online variant, anyone can upload the APK, and in dynamic analysis, that APK gets installed in the emulator. So for that reason, they do not want to expose themselves to a lot of attack surface. They mentioned that if you want to do static analysis, here is the application, do that. If you want to do dynamic analysis, here run this command, get yourself a Docker container, run it, and do the dynamic analysis. So here, once you upload the APK, they will be performing the analysis. This is the check implemented by Cloudflare here, so as to ensure that we are not a bot, we are not a robot. Yeah, so once this is done, we will be able to see the response of the static analysis here, the same that we will be able to get here. Depending upon how complex your application is, it will be taking time. For us to be able to save our time, I have we had already uploaded this app previously, and this is the result for a static analyzer. Here it is on MobSF Live. So here you can see a lot of things. First of all, you will be having the description. Like, this is the APK. These are the various trackers. Trackers as in the all of those components that are added into the Android application to track the user, like to track the user activity, to track the geolocation of the users, to track the user behavior. Privacy trackers, that is what these are. So this MobSF was able to detect, out of the 432 trackers that they have in their database, they were able to test the four. This is the file name, the size, these are the hashes. Hashes are provided here so that we can validate that the application that we are testing and the application that we had to test originally, both of them are same. This is the app name, this is the package name, com ombl cap campus m monash. This is the main activity. You remember when we were discussing about the Android application components, I mentioned about activity. Activity is each of the unique screen that you have on an Android app. So that is the activity. Main activity is the first activity that gets started, that is executed when you open the Android app for the first time. Then you open the Android app, the first activity that starts, that is the main activity. Just as in C and C++, you used to have int main, wherein you will be writing all of the code. So when you execute that, when you compile that C or C++ code, your compiler will directly be looking for the main function. That is where the execution starts. In Java also the same thing, in the Android also the same thing. The main activity is the first activity that executes when you open the app. Then the target SDK, minimum SDK, maximum SDK. We have already discussed about this when we were discussing about the. Okay, it looks like my system is lagging a bit. When we were discussing about the Android manifest files, I mentioned that target SDK is the you know version of the Android, the SDK, that is software development kit, where we are you know trying, or we are aiming that this is where our application will be working at. Minimum SDK is 24. on Android API level 24. This is the least version of Android that is support. So if you try to run this app on any of the Android device that has Android API level less than 24, now Android API level is associated with, okay, it looks like my system is lagging a bit. Let me try closing some of the Chrome tabs first, so as to save a few resources for the other processes to run. Okay. Hello, can you hear me now?